Great. Hi, everyone. Thank you so much for joining in for today's session. My name is Ivy Jepto. I'm a community manager at Nairobi DevOps Community, and I'm also a DevOps engineer. Welcome to today's session, and today's session will be led by Samuel Kadima. It will be on containerization with Docker. So thank you for tuning in. The quote of today is education without application is just entertainment. So that's just self-explanatory. The agenda for today is we'll have an icebreaker. We'll go through our meeting expectations. We'll know about the community, which I know most of you guys know, and then the session then we'll finish with questions if there will be any. So for our icebreaker today, if you were a car, which car would you be? If you are a car, which car would you be? That's a very interesting question. So I I'm not a car fanatic, but I think if I would be a car, I don't know the brand or the model or whatever, but I would want to be a four-wheel drive. Yeah. I don't know which one, but I would want to be like a four-wheel drive car. Are there like volunteers who want to tell us what car they would want to be if they would be a car? You can unmute your mic or you can engage us um, on chat. So let's see on chat. Uh, we have Rogers who's saying golf. We have Ian who's saying Ford Ranger. We have Kevin saying Rolls Royce. Nice. We have Brian who's saying a Jeep Grand. We have we have Morris who's saying a Pro Box. I would want Morris to unmute and tell us why Pro Box. We have Beshak saying a Bugatti. We have thank you for engaging. We have
Hello.
yes.
Yeah, my reason.
Go ahead. Okay, I think we lost you. We have Saab, we have G-Wagon, we have Subaru, we have a police car, we have Porsche 911. Oh, that's really interesting. We have Crispin who's saying, I've never had of, I'm not going to lie, I've never had that kind of a car before. Is there anyone who'd want to unmute and say the kind of car they would want to be? Going once, going twice. Okay, let's continue. Thank you for engaging with our icebreaker today. Those are really nice cars. Me pretending to know those cars. Um, so we have our rules where you have to mute yourself when you are not speaking. And if you want to speak, you can just raise your hand or leave a text in the chat box. Raise your hand if you want to speak, use the chat box to write your comments and questions. Be respectful to one another and be curious to learn. So about our community, our mission is to create a supportive and inclusive community that values diversity and supports learning and growth. Our vision is to be a leading DevOps community in Nairobi and beyond, driving innovation and empowering professionals to excel in their careers. So our team is our founder and director is Sam Kadima, who will be leading the session for today. We have Mamoon, who is the assistant director, Masilin Mochama, who is the community outreach manager. We have Samson Kalume, who's the programs lead. Ian Rutich is the treasurer. We have Alvin Dungu, who's the projects lead. We have Emma Gachoki, who's the events and social media manager. We have Lawrence Juma, who's the assistant event manager. We have Franklin Odd, who's the administrator. Then there's me, and then there's Daniel Orega, who's the assistant creative manager, and then Hugo Ivan, who's the assistant project lead. So that is the whole team. So if you would want to help our community, you can help us by running workshops and talks on topics that you are comfortable leading, and then connecting us with a DevOps professional who are going to help the community grow. And then you can also give us feedback on areas you would want us to improve. And then you can share your ideas on how to make the community better. You share our post and engage us on our social media channels. And you can also document activities and help us in organizing events. So we are going to start our session for today. Welcome, Sam. So if you have any questions, you can share it on chat, or you can raise your hand as well. Welcome, Sam.
Okay, thank you very much. So my name is Samuel Kadima, and I hope you guys are excited about the session. So I'm the one who is going to be leading you through the session today, and I am excited. So I look forward to a good session, and I hope that you guys are going to learn something from the session and use it to change how you maybe deploy your code or containerize your application. So in case you have a question as we go through the session, you can just type it on the chat, but you can also raise your hand and I'll be able to respond. So yeah, so that is how we are going to do it. So allow me to share my slides and then proceed. Someone with a question already? Oh, Thaddeus. I see you saying excited. I'm also excited. So this is good that we have the same energy. So okay, so we are going to look through our agenda and see what we should be expecting through the session, so that we can know what to expect. So the first thing that we are going to look at, because we are going to look at containerization, we need to understand what it is. And then after that, since we are going to use a tool called Docker to containerize our application, we also need to understand what Docker is. So we also are going to look at Docker architecture, and then we are going to look at a Docker file, how we can use it to create images, and how we can use those images to create containers. So we are going also to look at the container lifecycle, and then we are going to push our images to an image repository where we can that we are going to be learning about. So and also we are going to be able to run to create a container out of that image. So that is the goal of the day today. So let me go to the first thing, which is what is containerization. So I'd like anyone from the meeting to maybe share with us what they understand by the word containerization. So you can just unmute, you can raise your hand, and I'll be able to give you a chance to try. So you don't have to be right. So you can just share what you understand or what you think. Anyone? So George Okumu says putting things in a container. My thinking. Yeah, you are actually, yeah, that is what you're going to put something inside a container. Yeah. So that is, you're in the right line of thought. Anyone else? Anyone else? You can also raise your hand and feel free to comment. So what do you guys think is containerization? Yes, Thaddeus?
Hi, I can give my suggestion, even though I'm not sure. You put your your project in a container so that can be distributed among into different machines.
Okay, yeah, that is,
Yeah.
yeah, you're in the right line of thought, actually. Yeah.
Thank you.
So, yes. Oh, you said thank you. You're welcome. So, Maurice, was your hand up as well? I think I saw another hand up. Yeah. Do you, who was that? So, Igueta says, so let me see, look at the chat box. Igueta says, putting an application with all its dependencies in a package-like manner, which is now called a container. And then David says containerization is putting apps in a container so that they become lightweight and able to work in different operating systems. Hussein says packaging an application dependencies with the operating system. Oh, yes, it's operating system. Yeah. So, yeah, so I think you guys have some idea of what containerization is. So that we are going to look at containerization. So it's just the process of you packaging a container, packaging an application together with all its dependencies into a container. So that is what we are calling containerization. And we're going to learn about a container in a few. And what are these dependencies? So you're going to package an application together with dependencies. So applications, you guys, maybe you've interacted with many applications. You've maybe gone to Facebook, you've gone to YouTube, and you've used some software. So that software has been packaged. That is what we refer to as applications. So those are examples of applications. So there are things that those applications depend on for them to run efficiently. So the things that provision for their needs. So the applications have their needs. So they need some things, and without those things, they cannot survive. The same way you guys can need food in order for you to survive. So the applications need some libraries for them to be able to function as expected. So these are what we are referring to as dependencies or packages that they're depending on in order for them to function as expected. So if an application is dependent, for example, on a specific library, that library has to be packaged together with that application. So containerization, so that when that application runs in any environment, it has all its needs satisfied, so it can run efficiently. So I hope that makes sense. So you have how containerization works. So you are going to you have your server or your computer that you are going to work with. So this computer has an operating system. So what you are looking at here, you're looking at the infrastructure. These are the basic things that you need in your computer, such as storage. You have maybe networking, and you have on top of that, you have an operating system. So this operating system, you can be able to install applications on top of this. So one of the things that you install on this operating system is the container engine. The container engine is what is going to allow you to create containers or containerize applications. So we've said containerization. Containerization is the process by which you create containers, which basically package code or applications together with their dependencies. So you have this containerization engine that is on top of your operating system. And once you have that installed in your operating system, then you can use it to launch containerized applications. So that is a picture of containerization. And I think now we can look at containerizing applications now. So one of the container engines that we are going to look at, you see here in our graphic, we have our computer. If you buy a computer and install an operating system, it does not have a container engine probably by default. So you're going to install the container engine. So you install a container engine, and the one you're going to look at today is called Docker. It's one of the container engines that you can use. So we use Docker, and Docker is going to allow us to create containers. So we need to learn about this Docker for us to be able to use it. So what is Docker? Anyone who has interacted with Docker? Or anyone who will just try to give it a try? Basing on what I've said or what you've heard. What is Docker? Somebody's hand was up. Who was that? Yes, Dalton.
Yeah, hello, Samuel.
Hi, how are you?
I'm very fine. So I'll answer according to what you've just said earlier.
Yeah.
I'll say that, Docker is a software that, or this engine that helps us to host these containerized applications.
Okay. So it allows you to create the containers.
Yeah,
So
yeah.
that is true. So it is it is the platform that allows you to create containers and package your application into that container. So we have in order for us to use Docker, we've said that the first thing you're going to do is download Docker and ensure that it's on your operating system and set it up. So when you download Docker, there are some things that are going to be downloaded into your computer. It comes as a package, and that will allow you now to interact with it efficiently. And this is what constitutes its architecture, how it's made, so that you can be able to use it effectively and get the desired results. So we have a number of things that will be downloaded when you download Docker and set it up in your machine. So you're going to have a client. So the client interface is what you're going to interact with from your terminal. So the terminal is just, what do you guys call it? Well, how can I call the terminal? Which other name do you have for the terminal? It's like, anyone to give me an idea? Command prompt, or is it true? So yeah, so it's where so you can write command line interface. Yeah, command line interface. So that is the terminal. So depending on the operating system that you are using, it may not be called terminal. So it may be something else. But if I believe if you're using Linux or Mac, you're going to it's called the terminal. So the terminal will allow you to interact with your computer, send instructions to your computer. So the Docker client is what you're going to interact with. Command line, the Docker command line interface is the Docker client that you're going to interact with. You're going to give it text commands, and these text commands are going to be transported to a specific place, which we call it the Docker daemon. So the Docker daemon is the backend of Docker. So you have this Docker backend, which is like the kitchen where everything is cooked. So if you want to create a container, you're going to interact with the Docker through the Docker client to give the instructions. And we've said these instructions are expected to go to the Docker daemon. But how are they going there or getting there so that they can be executed? They're getting there through the Docker API. So we have the Docker API that will allow you to transport the instructions that you are giving through the command line interface or the Docker client so that they can be transported to the Docker daemon. We say the Docker daemon is like the kitchen. If you go to a hotel and you give instructions on what you want to eat, you tell a waiter. So the waiter is the API. So you're expecting something. So you go to the table. The waiter will come to you, and you're going to interact with the client, with the waiter at that table. So assuming that that table is the client where where you have to sit so that they can approach you, and you can now get in touch with the API or the waiter. So you can talk to the waiter, and once you've done that, the waiter can go and serve you make a request in the kitchen for a specific meal that you want to eat. So if you maybe, for example, request for ugali and bones, that is what they're going to request. Another person will not request the same thing as you. So somebody will just say ugali and soup. Another person will say bones plain. So the waiter will be taking those instructions, and all of these things are going to be prepared according to the request. So that is the analogy of you making a request through the waiter. to the kitchen, and then from the kitchen, once your meal is ready, the waiter is going to serve you and bring you the result. So at your table, you're going to receive what you requested. So the Docker architecture, you make a request from the client, Docker client, and then that is the command line interface. Once you do that, the Docker API is going to take that transaction that you are making and take it to the Docker daemon, which is the backend. So if you're just trying to see, for example, which kind of images you have in your container, in your system, you are making that request. I want to see all images that are present here, or all containers that are present here. So the Docker API is going to take that instruction to the Docker daemon. The Docker daemon is going to go through the database and see which images or containers are available and present them to you. So it's going to search for exactly what, according to the command you're giving, is going to cook for you that data and present it to you. So you can look at that. If you want to create something, for example, you're creating an image, creating a container, it's going to do that as well, according to the instructions that you've given. So I hope that makes sense. So that is the architecture of how Docker looks like. So all these things that you're going to do through the Docker daemon, for example, you create an image. Once you've done that, you are going to save your images in a repository. So a repository is like a bank. So the repository that you're going to save your images when you're working with Docker is called Docker Hub. So Docker Hub is the registry where you can store Docker images. So once everything has been created, you can be able to push the images to Docker Hub. And then after that, you can pull those images and create containers using those images. So I hope that makes sense.
Yeah, Sam, before you continue, we have a question from Michael. He's asking, what are images?
Okay, Michael. So Michael, we are going to tackle images in a few. So just be patient a little bit. Okay, good. So somebody here is asking, from cloud computing model, is Docker a set of PaaS, platform as a service? So Docker is not a platform as a service. So because in platform as a service, you can only get the infrastructure that you require, and you can set up everything else that you need on top of that. So you can install software, you can watch movies, you can do anything on platform as a service. You can decide what you want to do. But Docker is I can call it, no. That what I'm talking about is not platform as a service. That was infrastructure. So what is Docker actually? I think, yeah, it can be platform as a service. I think it could make sense.
Okay.
Yeah.
Samuel.
Yeah.
Yeah, let me answer him what's Docker. Okay. What's a Docker image? A Docker image is just a file that you write that executes code that builds the whole Docker container. That's a Docker image.
Okay.
Yeah, and it's not a platform or service. It's kind of like, let's say, do you guys know of a VM, like a virtual machine or something? Yeah, Docker is something like that.
Okay.
Yeah.
So I'm not so sure about whether it's a platform as a service, but I think platform as a service, basically, what they help you with is a platform as a service will have everything already set up for you. So it's going to do a specific thing. For example, you want to deploy software, it has the environment set up for you. It could be. So I have to, maybe I'll have to look into it and ensure that, in order to confirm if it's a platform as a service. But in case anyone here in the meeting is clear about that, you can just write in the comments. So I'm going to take questions in a few. So when you want to speak, ensure that you raise your hand before you speak. So I can see some hands, but I'm going to respond to that in a few. So here you're saying, what are Docker files, Docker images, and containers? So those you said in order for you to end up with a Docker container, there is some process that you're going to go through in order for you to arrive at a container. So the first step that you're going to do once you have Docker installed in your computer, you are required to maybe set up, you already have an application that you're going to work with. From that point, you need to create a container to containerize that application. The first thing you are supposed to do is write instructions. So now you're going to containerize that application. So that you're going to do in a Docker file. So the Docker file will contain the instructions that will guide you on how to that will guide you to on how that will define how your image is going to look like, and which kind of commands maybe should be executed after the container has been created. So once you have your image, you can create your image. So once you've created your image, at that point you can go ahead and containerize your application from that image. So we are going to look into that when you go into the demo in a few. So you have a Docker file. So the Docker file it will help you create a Docker image. This Docker image can be used to create a container. So that is the process that we are going to follow. And then the other thing that we need to look at is the Docker container life cycle. So how, once we've created the container, which kind of life cycle do we have in the Docker process? So we've said the first thing that you need to do is create an image. Once you have an image, you can go ahead and create a container. Once the container is running, you can be able to post the container, stop the container, and post the container, and start the container. So the container, while it's running, you can be able to do some things. You can be able to exec into it. You can to collect some logs of the container while it's running, and you can be able to monitor the container. So once you are no longer using a container, you can stop the container, and you can even delete it. So at that point where you've deleted the container, it's no longer accessible. So when you have an image for a container, we've said you start by creating an image. When you create an image, that image has layers. So this image has layers, and these layers, the image you've said for you to create an image, you're going to create it from a Docker file. So the Docker file, you're going to write instructions of everything that you're going to do, and you're going to do everything on a separate line. So every line that has instruction is regarded as a different layer, a separate layer. So all these layers in the Docker file, you're going to create an image from this Docker file. And once you create an image from this Docker file, the image becomes immutable. So you cannot be able to edit that image. So in case you want to add any features to your Docker file, or you want an image with more features, you are going to have to edit the Docker file again and build a new image. Every time you launch an image, it's going to launch an image with a new ID. It's not going to have the same ID it had before. Even if you launch an image right now, the moment you launch it again, it's going to launch from the same Docker file. The moment you launch again, it's going to launch a new image with a different ID. So you can be able to launch millions of images from the same Docker file in the same machine, and it will not have any conflict because they're given unique IDs. So you launch new images. So you build new images. So once you create new images, you can use these images to create containers. So these containers, we've said images themselves are not immutable. So you cannot be able to interact with an image once it has been created, unless you create a container. So you create a container, and that container, once you create it, the container now creates a writable layer, a layer that can allow you now to maybe, that is editable, a layer that is mutable. So this writable layer is only created inside the container. So while the container is running, you can be able to access this mutable layer, and you can be able to store some data. You can be able to interact with the container, read from the container. That will be possible for you to exec into the container and do something. The moment you post a container, you will not be able to access the contents of that container unless you start that container again. So the moment you start the container, if you post it, everything that was within that container will have been persisted inside the container. So when you unpost it, you're going to be able to access the contents of that container. But the moment, if you stop the container as well, you can stop it and then start it. The contents that were inside that container are going to be accessed after you start that container again. But the moment you stop that container and it's not running, you are not going to be able to access it. So you have to start you're not going to access the contents of that container or the data inside that container. So you have to ensure that the container is running in order for you to access any data inside that container. So when you say you've stopped the container and then you delete the container, since the data was saved within that container, that data will get lost. So you'll no longer have access to that data. So that is why there are other ways that we used to store data for a container, so that when you delete it, we delete a container. When the container goes through this life cycle and is deleted, for example, you are not going to lose your data. So let me go to the next thing, and then I'll take, this is the demo actually. So I think I can take some questions there, and then I go to the demo. So the thing that I've said, so what you will do in order for you to ensure that when you are, maybe your data is not deleted, you're going to use Docker volumes. So Docker volumes will allow you to store your data. So these Docker volumes are storage resources that are going to be outside your Docker container. So what you're going to do is map maybe a folder inside your Docker or a directory inside your Docker container to a file system. So normally what happens in every file system, there is a location called var that has a path var lib docker on the file system where you can be able to store Docker resources, or where you store that, you can be able to store, create your volume and attach it to that location. So we have, of course, we have different types of volumes that you can use. But the one that, these different types of storage that you can use in Docker, but the one that is recommended is Docker volumes. So we have temporary file systems, and we also have mount points. We have, what do we call them? I think the name has disappeared from my head. If anyone knows, maybe they can type on the chat. So we have, yeah, I think it's something mount. So we have those. So what else did I want to say? So in order for containers to communicate, you'll need a network. So there is also Docker networking that will allow you to communicate within your containers. So I think that is what I can say. And I can take a question. So for today, we are not going to cover everything about Docker, but we're just going to look at containerizing applications. And in case you want to read about the other things, maybe like networking, you need to read more about storage and anything else that is available in Docker. You're going to have to do that maybe on your own, or join a bootcamp like Moringa School and learn that. So I can take a question at this point as I go to the demo. So do we have any questions? We can hear from Maurice.
Okay, yeah, and my question is a little bit technical, but I had this problem a while back. I was creating my Docker container and it was 181 MBs, but that's quite big because that's Alpine. So what can you like recommend on that? How can I like make it to become a little bit smaller, like let's say 50 MB megabytes? Because
Okay.
like it's something like cost cutting. So how can you like give me an idea on making it becoming a little bit smaller?
So in case you want to make it smaller, you can use multi-stage builds. I believe that will, when you are creating the image. So I think that will make you meant your image to be smaller, or what did you mean?
Yeah. I wanted my image to be smaller and
Yeah.
to use bare metal.
Yeah. So you can use multi-stage builds. So you can check on that. I think that will help you.
Okay, sure. I will.
Yeah. So let's hear from Dalton. Hello, Dalton. Dalton, you are on mute again, so we can't hear you.
Yeah, I'm saying I raised my hand by mistake. Sorry.
Okay. So you can hear from Maurice. Maurice, you are the one who spoke.
Yeah.
Yes, and show you. Okay. So, we hear from Gilbert.
Hello, everyone. I hope I'm audible.
Yes, you are.
So, another suggestion, Michael, on how to minimize the size of the image. You can also multi-chain the commands. Instead of running like multiple run commands, you chain them into a single command so that the layer reads like it will create a one layer instead of creating multiple layers for the images. Yeah.
Okay. So even for the layers, there are some things that are best practices that you need to do. So you want to separate the layers so that each layer is not dependent on what is happening on another layer. So that in case you change something, let's say in your Docker file, and you are building that image again, you want it to take the least time possible. So when you are creating layers, you have to be aware of that so that you don't just maybe bind all the layers together, and then when you change something, a little thing, you are ending up maybe rebuilding the entire application when it was because you guys when you just need one thing to change. Yeah. So let me go to the demo, and then we'll have questions at the end.
There are some questions on chat. I don't know if you have seen it, or you'll tackle it after the end.
So you can read for me as I switch.
We have from Ratemo. He's saying, I don't know if images are deemed or said to be immutable. What is the reason behind this characteristic? Why can't it be updated?
So you're saying, are you able to unmute the person who asked the question? So if images are immutable, what is the reason behind this? So you create an image. You see, like the reason why you create an image is because you want to create. You want to use that image to create things that are the same all the time. So if I create an image, for example, or you guys have already used an image, so you've used an operating system. So you are given something like the image for your operating system, which may be installed in a flash disk or in a CD drive. And after you did that, you went ahead and use that to you plugged it into your computer and you are able to launch a software. And that software, if you launch it on your computer, another person can go and launch it on their computer, and everyone else can be able to do that. It should perform the same. It's expected to give the same result. So the images are not immutable because when you create an image, you want to be able to use it to create containers, and the image should always give the same results. So that is the reason why you are not able to. I believe you are limited from editing an image. So does that answer your question, the person who asked? Okay, is there any other question? Can you guys hear me?
Yeah, we can hear you, Sam.
Is there any other question?
Okay, the person who asked the question has said that you have answered it, but then we have a question from George. He's asking, out of curiosity, what happens to the data in a container when it's removed? And then he's gone ahead and said, could you talk a little on how volume persists data?
Okay. So you guys have interacted with maybe an external drive, let's say a flash disk. I can just use a flash disk. So you have a flash disk and you have your computer. So when your computer is running, your computer is on, you can be able to access data in your computer. So you can be able to access your file system and be able to look at the data, be able to do something with that data. So the data I'm referring, maybe you've downloaded some videos, you can be able to access those videos. So but the moment you shut down your computer, you'll not access that data. So once your computer is shut, you cannot access that data. But if you have a flash disk, you can take that flash disk, or your computer is spoiled and it's not powering on. You can, maybe it may not be easy for you to access that data unless you get the hard drive, of course. But assuming you cannot get the hard drive outside of your computer. So now when you're having a flash disk, you can save that data on the flash disk. So if the computer gets spoiled, and assuming the computer, there is no other way of accessing the drive, then at this point you have data in the flash disk, you can go and plug it into another computer and you can access your videos or your data. So when a container is not running, you cannot access anything inside that container. So it has to be running for you to access it. And containers are created with the purpose of, so that they can aid us in maybe creating microservices and doing orchestration. So when you want to manage systems where containers are being spin up automatically, when they are not healthy, they're shut down. Then if a container is shut down, we've said it's not going to be restarted. Once it's shut down, a new one is going to be created with a new ID. So if the previous one had data, that data is going to be lost. So what you need to do is to ensure that you have a volume. So a volume is like this external flash disk that will store your data. So in case the container got spoiled, or it's not working, it's deleted, you can still have this data that can be accessed by another container. Does that make sense? Okay. So I think Ivy, is there any other question? I can take the last one if there is any.
I don't think it's a question. It's more of a continuation of the question of if Docker is a set of platform as a service.
Okay. So I think we can confirm that and share that. So those who are in the group can share that in the group, or you can join our group and then we can continue the conversation of whether Docker is a platform as a service there. So for now, I have this repository that I've created that has instructions on what you're going to do today, and it has the application that you're going to work with. So I'm going to share with you so that you can clone and you can be able to work with it. You can be able to see what we are doing. So you can fork it into a repository or just clone it. So that is dependent on you. So if you want to have this copy on your end, so that even, let's say I delete it, you still have that copy. So you can fork it. So what we have here is a project that I'm going to take you through. This is the final project that you're going to work with, but I think I can just create it as we go so that it's easy for me to explain. So on this project, I have resources here. So these resources that you are looking at here, these resources will help you go step by step. What we are covering here, I've written an article called Containerization with Docker. So you can go through that article at your own time and follow the steps and be able to containerize an application. So there is an application I've given there, but you can also containerize this application. So, and you'll be okay. So yeah, so that is basically it. So if you want to join the Nairobi DevOps community, these are the links that will allow you to access that community. And then in case you want to connect with me, you can click on that LinkedIn there, and you can be able to connect with me on LinkedIn, maybe ask questions or in case you want maybe any engagement with our community or with me. So I think you guys have access to that code now. So I can go ahead. So for now, I'll just go ahead and create a project. We'll start afresh. But basically, what we are going to do, as if you follow along, you'll be able to go through that code and everything will make sense to you once you go through it. So what we have here, we have the project is a Python Django project. And then the images, as this image that you are seeing here. And then we have a README file. This README file is the one that has what the documentation, what you are seeing here. And then we have requirements that has our packages. We have manage.py, this CWD project app, and and app, and db.sqlite. Those are part of the application. They make up the application. And then we have this license that allows anyone to use this code. And then we have git ignore that specifies some files that I should not be able to push to GitHub. I should ignore when I'm pushing to GitHub. So that is basically what we have in this project when you clone it. But let me just go and create a new one from scratch so that it can make sense. So let me share my entire screen. So it's just a simple project, so you'll be able to create it in a few seconds or in a few minutes. So let me share my entire screen and go to my terminal. So I believe you can see my screen now. You can see my terminal.
Yes, Sam, we can see your terminal.
Okay, good. So on my terminal here, I'm going to go ahead and move to a directory where we're going to work from. So I'm going to go to code and then development. So I'm using cd command to go there. I'm supposed to go to code to development before I go to code. Development and then code. Yeah. So inside here, I'm going to create a directory, and this directory, I'm going to call it. Can call it our. Let me call NDC. NDC is Nairobi DevOps Community. Containerization. So that is the name of the folder that I'm creating, and once that folder. Oh, I misspelled. So in order to create a directory, I'm supposed to use mkdir to create a directory. So that directory has been created. So I have to navigate into that directory using the cd command again and move into that directory. And I'll be able to access. Once I'm inside the directory, I can go ahead and perform the task that I want to do. So what I'm going to do here, I'm just going to open the code editor. So that is the thing I'm going to do. Once I have my code editor, this is where I'm going to work from. So I'm using Visual Studio Code. So on Visual Studio Code, I'm going to create a sample application. So for the sake of those maybe who do not have, maybe they are from networking field or they're not in the field of software, that is the reason why I'm creating this simple application for you just to see sample software, so that it makes sense to you. So here, what I'm going to do, because I'm going to create a Python application. So for you to, Python has a package manager called pip. And in order for you to follow along and to be able to do what I'm doing, the prerequisites that you should be having is Python set up in your system. And I'm using Python 3. So Python 3 should be downloaded in your system. And you should also have pip installed in your system. So once you have those two things, you should be able to create this project. So I'm going to create a virtual environment. So I'm going to do Python 3. So the reason why I'm creating a virtual environment is so that we've said an application has dependencies. The dependencies or the libraries that we are going to install for this project, I don't want them to conflict with any other dependencies that are available, or libraries that are available on my computer right now. So I have to create a virtual environment that will be a separate environment from the environment that the rest of the libraries are running from in my computer. So I create a virtual environment, and I'm just going to call it .vnv. So that is the virtual environment that I've created. So once I've created the virtual environment, you can see it here on our folder. We have created a virtual environment. So the next thing I'm going to do is to activate that virtual environment. So you can use a dot, or you can say source bin activate. So you do a dot here, or you say source, and then you name the virtual environment that you want to activate. So it is .vnv, the one that I want to activate, and I go to the bin folder. So inside the .vnv, there is a bin folder. Inside that bin folder, I can be able to activate. So once I activate, you can see my terminal has changed, and now I'm inside the virtual environment here. So once I'm inside the virtual environment, now everything I'm doing inside this virtual environment will be separated from the rest of the things that I'm going to do into within this project. So I'm going to use a Python framework called Django. So for me to do that, I'm going to use the module called pip that I've told you need to install first. So I'm going to say pip install. I have to install Django first within this virtual environment. So once I've installed Django, I can go ahead and create the application, the Python application using Django, because Django is a Python framework. So that is successfully installed, as you can see here. So successfully installed everything. So that is required for Django. So once I've done that, I can go and create a Django application. So for Django application, I need to create a project, and the project will contain the settings or the configurations for my Django application. And then I can be able to create an application or different applications, separate different concerns that are within this project separately, using by creating different applications for specific services that I want to create. So I will start by creating a project. So for a project, I'll do Django admin. Django admin. And then I do start project. Start project, and I give this project a name. So I can give it a name that describes it. So the project that you are going to create, for example, for today, we can say, let me just call containerization demo, or yeah, let me just call it containerization instead of making it too long. Containerization. And then I want it to be created inside this context. So I have to add a dot there. So once I press enter, yes, somebody's hand is up. You can speak. I think I've written this Django admin incorrectly. Let me add n there. So once you've done that, so that n was missing. I had written Django instead of Django. So Django admin start project has created this containerization project within this directory. So let me admit that person. Is somebody helping me to admit? I think somebody is helping me. Okay, yeah, somebody is helping me to admit. That is good. So this containerization here is the project that we've just created. And what you get here, you get init method, you get SGI, you get settings, URLs, and all these things. So the main thing that I want us to look at today is we'll just look at URLs and settings. That is where we are going to alter some things. So the rest of the things important for today. So in case you want to learn about Django, you can go and learn about everything else. and you'll be okay. So let me go ahead and once I have my project, I've said I need to create applications that I'm going to work with. So in order for me to create an application or app that I'm going to, I've said we create different applications to separate concerns. But once you've created these applications, we have to register them in the project so that the project can know I have these applications that I need to work with, or different services or microservices that I need to work with. So I can say Python 3, or you can still use Django admin start up, or Python 3. Either of them will work. Python 3. But now I'm going to use manage.py. You see, when we created a project, in our root directory, there is a file called manage.py that was created, which is an entry point for Python. So I do manage for a Django project. So I do manage.py. It's not writing on my terminal, manage.py. And then I start up. And the app I'm going to create, I can just call it app actually. So once I've created that, you see there is a folder called app that has been created. So the first thing that I need to do is to register this app inside our project, which is the containerization project. So I go to the settings and I go to installed applications. So I want to install app. So here I will add it here inside installed apps. So here I will add app. And then inside apps, I can go to apps. So if I expand this, you can see there is apps.py. So I can go to apps, inside app. And then here I can go to apps config, the configuration for that app. So I will have registered that. So if I click on this app, app, and then apps, if I click on it, you can see there is app config. So that app config contains the configuration for that application that it can be accessed in order to run this application. So that is what I'm going to add there. So once I've done that, I've registered my application. So the next thing that I'm going to do is allow all hosts on these settings. So I'm inside the project. I'm going to allow all hosts. But here is where you can specify the hosts that you want your application to access, maybe when it's running in production, so that it maybe doesn't allow just any hosts. So for me here, I'm going to allow all hosts for this project. So that is our settings. We are done with that. We are not going back there. So the next thing that we are going to look at is urls.py, which contains our paths or our endpoints for our application. So here, because we've said we've created an application and we want to link it, when you access this project, you should be able to access this app. So we are accessing it through a path. You're going to type a URL on your browser in order to access this. So I have to specify that path here. So I have to specify the app, where the app is located, the path to the app, so that when I go to the app, I can put all the paths that I need for that app. So here, I'm going to, when you go to the home URL, when you hit that browser, or when you open this site application on the browser, what is the default thing that should happen? So here I'm saying here, I want you to include all the URLs that are present in the app. So currently in app, we don't have any URLs we are going to create. So I'm going to use an include module that is available here that I'm going to import from Python. So this will allow me to include the URLs in app. So, and here I can just put in quotes and say app, because we've called our app. And then I'm going to access URLs inside app. So inside app, I should access URLs. But if you go to app, there are no URLs. So let me close this containerization. We don't have a file called URLs. So I have to create that file here. So I create a file called urls.py. So once I've done that, here is where I'm going to specify the URLs. So the structure of the URLs is just the same. So the URLs that you have in this main URL in the project is just the same structure. So I'm going to copy this here, and because I just need to import path and add the paths that I want to visit on this app. So in urls.py, I'm going to paste this that I've copied from there. I'll remove this admin and remove this include, because we don't need it here. So I'm going now to mention the paths that I'm going to use inside here. So which paths do I want to visit? So when somebody visit my application by default, when they visit the home directory, what do I want them to see? So inside the home directory, once they visit the website, the default directory, what I want them to see is a method should be invoked and present something on the browser. So this method is going to be written inside views. So in Python, I'm going to anything that you want to present on the browser. When you're working with Django, you're going to write it inside views, and then so I will go into that views, and here I'm going to create a method that will present some information on the browser. So here I'll say from Django, Django.http, because I just want to represent some response on the browser, HTTP response. HTTP import HTTP response. So that is what I want I want to use it to represent some information on the browser. So I'm going to create a method. So I'm going to create a method, and I'm going to call this method index, or I can call it any name. So index is just a name that means maybe the default route, that when we visit the default route, I should be able to, this is what I should expect. So this can return something like an HTML page, but for today we are not returning an HTML page. So yeah, this is going to take a request. So when you get a request object, and then it is going to do something after you send a request to this method. So once you get this request, I'm going to return some information. And this information that I'm going to return is going to be packaged inside the HTTP response. So HTTP response, and I'm going to return some message. So I can write what I want to be presented in the browser here. What should someone see on the browser when this method is invoked? So here I can say, I could say hello world. So but let me say hello DevOps. Hello DevOps. This is the application. We created while learning containerization. So this is the information that we are going to see on the browser. So we have our application. So, but this method, we've said we have to be able to visit a URL in order to see this. So if I go to urls.py, I've not invoked this method when anywhere. So I want it when you visit the default URL, I want it to be invoked. So, but that method is inside views. That is why we've written it inside views. So since that is the case, I will go back to our URLs and import views. And views and urls.py are in the same location, in the same context. So I'm going to import from that context. I'm going to import views. So once I have views, I have access to views. I can inside views we have the index method, so I can access that index method that we've just created inside views here. So I can go to back to URLs and invoke the index method. So I can say views. Inside views, if I put a dot, I can be able to access the index method. So once I'm able to do that, I can decide to give this URL a name, or I can leave it like that. So I can say name is equals to index. So once I have that, I should be able to visit the browser and see my application. So in order to run this application, I'll do Python 3 on my terminal, manage.py, run server. So once I do that, my server starts running, and I can click on control and click on this, and I should be able to see on my browser that whatever we wrote is being presented on the browser. So we've been able to create the application that we are going to use. So that part is done. We have our application. Now we can go ahead and containerize it. So when we containerize it, we should be able to still see this on the browser inside the, when we run the container, we should be able to see this. So our application is working as expected. So I'll go back to the terminal, and I don't need to serve it anymore. So I can end the session. So it's not serving anymore, but we have our application that is running. So you've been given this application as a DevOps engineer or a developer, and you need to containerize it. You said the first thing that you're going to do is create a Docker file. So in order to create a Docker file, I'm going to create it in this by using touch Docker file to create a file here called Docker file. So you said this Docker file is going to allow you to specify the instructions that you are going to, that on how your image is going to be created. So you can use minimal. So when you are creating a Docker image, you are going to use you are required to use a minimal Docker. You are going to use a base image. You are going to start somewhere and build on top of that, because when, for example, when you're working with Python, you remember I told you when you are working from your computer, in order to build this application, you'll have to install Python, install pip for you to get started. So, but when you are working with a base image, all those things are already set up in the base image. So you are not going to install Python again. You're not going to install pip. So because the base image has everything that you require that suits that application. So in our Docker file, the first thing that we need to do, since this is a Python application, we use a Python base image. So you state the base image using the from instruction, and you state the base image. So I'll just use Python. So this may not be the smallest image that you have, but you can go to the Docker repository and find out which other lightweight images are there, or smaller sized base images that you can use. So, and this actually will add to the size of your image. So you ensure that you choose the smallest for you to be able to have a smaller image. So here, once I have my base image, the next thing that I need to do, because we said when you're containerizing application, you're containerizing an application together with all its dependencies. So you have to ensure you do that. So first, before I do that, I'll ensure that these instructions that I'm writing in the Docker file, I'm writing them so that I can be able to create a container. So inside that container, I have to be working inside a directory. So I'm going to specify which directory I'm going to work from. So I use the command workdir. So this command will create a directory and change directory into that directory, move into that directory. So inside the container, from this command down, the next steps that I'm going to write, they are going to be working inside this directory. So I'm going to call this directory app. So once I have this directory, workdir has created a directory and navigated me to that directory. So now I'm inside app. Inside app, I can go ahead and copy the dependencies. So, but inside here, you can see on my local machine, I don't have any dependencies because there is no file that specifies the dependencies. We say that dependencies are stored in a file called requirements.txt, but that file does not exist. So I should be able to create that file here. So in order for me to see the dependencies that I have within this virtual environment for this application, I can do a command called pip freeze. So pip freeze will display all the dependencies. So these are displayed on my terminal. But what I want to do is to store these dependencies within my project. So I will have to write them. So, or append them to a file. When I run pip freeze, so I can copy and create that requirements.txt, or I can just run one command that will do everything. Instead of me copying, I can append that automatically. So I can do pip freeze. And then this will append. This angle bracket means append. Not append, actually it means write. So it will write into that file. So I'm going to write into a file called requirements.txt. So if the file exists, it's going to override it with the information I'm providing. But if the file does not exist, it's going to create that file. So everything that is printed on the terminal here, when I run pip freeze, this output, I want it to be written into this requirements.txt. So once I run that, a file called requirements.txt has been created here. And if I open, I can see the dependencies that we had in the environment are all listed here. So the importance of us being in an environment now, if we were not in the environment, it could have listed all dependencies that are present in the computer and we'll all have all of them highlighted here. But now we are only having dependencies that we require for the application. So once I have these dependencies, I can go and copy these dependencies into the Docker file. So that I can install them. So what I'm going to do is use the copy command. So the copy command, and I'm going to copy requirements.txt that are in this on my host computer. So requirements.txt from my host computer, and I'm going to copy this requirements.txt to the context that we are in. You remember I've said we are now inside app. That is the context we are in. So I'm copying that into that. So once we have that, the next thing that we can do is install this requirements.txt, install the dependencies so that we can package our application with its dependencies. So when we run the container, so here we can say, in order to install, I can use the run command and state which command I want to, which command should be run. So I use run to specify which command I want to run, but the command I want to run is pip. We used pip install previously, so that is the same thing we are doing. So pip install, but here we are referring to a file that already exists. Initially, we are just installing Django with pip, but it did not exist within this environment. But now we have access to the requirements. So we can refer to that file, requirements.txt. So that will install all the dependencies. After the dependencies have been installed, the next thing that I'm going to do is I have the dependencies. I have now I do not yet have my application inside this. This image does not have access to my application yet. So I have to copy the application. So I will copy again everything from my current context, on my host machine. So in my current context, which is NDC containerization folder, I'm going to copy everything there into the app location. So in context in my computer to the context inside my container, where my container is going to run now. I have the app. So once I've done this, the app we have the app and we also have dependencies. So you can go ahead and run our application. So I'm going to, in order for me to run our application, we said the image, once the image has been created, it's immutable. So you may not even be able to do something on that image unless you're interacting with it, maybe deleting it or describing it, maybe seeing some information about it, but you cannot change anything about that image. But now I want to, once this image has been created, I want some commands to run by default when a container is created from this image. So I'm going to use a cmd command to specify which command I want to run inside that container once it's created. So the command I want to run is the command that will allow me to serve the application. We say the python manage.py run server. That is the same command I'm going to run here. So since it's a Python application, so that is the same thing I'm going to run here. Manage.py, and then I run server. So once I run this command, the next thing that I need to specify is the port for this container. So I can specify that. So on this container, I want to run it on port 8000. So I'm just using the same thing that is on the application you have cloned, so that it makes sense when you go through that application. So that is our Docker file. So we are done with our Docker file. So we've created we've written the instructions for our Docker file. So the next thing is to create an image. So from this Docker file, we should go ahead and create an image. So to create an image, I'm going to use a command called docker build. So first of all, in order to create a before I create this command that will allow us to docker build, I'm just going to take you to the Docker repository. So we've been able to write instructions. We've not created an image yet. So these are just instructions on how to create the image. So I'm going to take you to Docker Hub. So on Docker Hub, Docker Hub is the repository that we use to create images. So I'm going to take you there. And on Docker Hub, you are going to, you create an account on Docker Hub and use your username. So I'm going to Docker Hub. So let me go to my browser. And let me open that browser here. Oh, it's this one here. Okay, so here I'm going to Docker Hub. So I go to dockerhub.com. I want to log in into my account. So I sign in. I believe you guys can see my screen.
Yes, you can see your screen, sir.
Yeah, so once you sign in, you've created an account with your username. Your username will appear here next to this stamp. So that is your username. So when you are tagging or you're building an image from a Docker file and you want to push that image to Docker Hub, you have to ensure that you start with your username. So that username, mine is Samuel Kadima. So when I'm tagging the image or building an image, I need to tag it with that name. So let me go ahead and let's build an image. So let me increase the size of this terminal a little bit and then clear what we have here. So I'm going to, I've just used Control L to clear. So let me go ahead and create an image. So I'm going to use Docker build. So the command I'm going to use is called sudo docker build. So you can also use Docker build without sudo. Is there somebody with a question?
Yeah, I have a question.
Yes.
So, like, whenever you're doing this, does it mean also like you have to ensure that the Docker is also running on your application? Let's mean the local machine rather than in the VS Code. Because like recently I was trying to do a containerization using Docker, but then
Yes.
I wasn't able to containerize without using the Docker login on my local machine, like through the terminal.
Okay.
Things were not. Yes. So that was just a question.
Yeah, so Docker should be running. So Docker, you have to ensure that Docker is running. So you might have installed Docker. Docker might have been installed, but it's not running. So you have to ensure that it's running. There is a command that, what is the command? I think I've forgotten the command, but I will share with you by the end of the session. Probably I'll have remembered that. Can I enable you to see if Docker is running?
Okay, sorry. So like right now, your Docker in your local machine is running.
Yeah, Docker, once you've installed it, it's enabled, it's running.
So
right now,
it's a
Docker engine. Yeah.
Yeah, so you don't have to always Docker login all the time whenever you're doing this.
I will log in when I want to push to Docker Hub, but right now, I've not yet logged in, so I'm not yet there. So right now, I'm able to use Docker commands because Docker is running. If it was not running, I couldn't be able to use Docker commands.
Okay, thank you.
Yeah. So I will build this image. So I'm using an image from this Docker file. I'm going to build it. And when I build it, I'm going to tag it with a name so that I can easily identify it. So I've said I use the Docker Hub username. So you can see the Docker Hub username is Samuel Kadima. So I start with that one. Samuel Kadima. Then once I've done that, I give this image any name I want to give it. So I can give it any name. So I can say our containerized image or something. Containerization tutorial. Containerization tutorial. So let me say tut instead of tutorial. and then I give it a version. So when I'm giving it a version, I have to ensure that I'm using semantic versioning. So I can give it a version. So I can call it version 1.0.0. So when I come and edit anything on this Docker file, let's say I come after some time, I'm adding more features to this image. So I have to edit the Docker file and build another image. That image will be of a different version. So I can, at that point, I can give it another version, depending on the changes I've made, or maybe if my application has different changes, I can change the version of. That will guide how I'm going to change. So here on Semver, go and read about Semver versioning. It will guide you on how you're going to tag your images with the versions. The versions, maybe when it's a minor version, a major version, so such things. So, or just maybe you are solving a small bug. So that will guide you on which values you're going to change. So you've seen applications with version 1.00. There is a point where you can change this last 0 into 1. There is a point when that is you leave that 0 and change the second one, depending on the magnitude of your changes. So read about that and it will make sense to you. So I've tagged I want to create an image, and this image is going to be called Containerization 2 tut, and the version is version 1.00. And I'm building this image from this context where my Docker file is located. So I have to specify that with a dot, that is the context of my Docker file. And I press enter. I put my sudo password and it should build. So once I've done that, now it's building. And what you can see now, these are the different layers that are building layer by layer. So once it is done, we are going to have an entire image that has all the layers that we required for that that we specified in our instructions in our Docker file. So now we wait a little bit for it to finish. So I didn't write pip install, I write pip install. So I have to ensure that I wrote that correctly. So in line 7 in our Docker file, so let me change that into install. So I've now written install. So that is the correct syntax. So once I've done that, let me just clear this terminal and rerun the command. So this command that we're using to build. So once I run it again, and now it should work, I believe. There is no any other error. So I think it's now it's installing the requirements that worked as expected. You can see that here. They are being installed in the image. So once that is done, now it can copy the entire application. That is our next step here. Once it is done, now we are good. It has copied the entire application. So when you have said this CMD command is going to run when you create a container. So let me clear my terminal. So our image is already created. So let me do clear this terminal first. And once I've done that, I'm going to run a command called docker images. So once I run docker images, I can look at the image that I've just created, which is this containerization tut version 1.0.0. So that is the image I'm going to use. I'm going to push it to Docker Hub. So I copy this. You can run it. You can just run it if you want to run it, but you can push it to Docker Hub and also access it from Docker Hub. So, but let me, what do I do? Let me just run it first. Yeah. So let me copy this and then we'll push it to Docker Hub. So in order to run this, I'm going to do Docker run or Docker container run. So let me just clear this. So I do Docker run. And when I'm doing Docker run, I want to view this from now I'm running this Docker run from my computer. So if I'm running it from my computer, I have to attach a port. There is a port that I should be able to access from my computer. and this port should map to the port 8000 inside the container. So I'm just going to map a port. So I specify a port using the -p flag, and then I do the port that I want to map from my local machine to the one inside the container. So that is the port I want to map. And once I do this, I can go ahead and specify the image that I'm running. So I'm running an image. I'm going to run a container from an image, and I want to map it to this port on my host. So port 8000, when I access port 8000 on my host, I should be accessing port 8000 inside the container. So, but the image I'm running is this Samuel Kadima. So I didn't write the name correctly. I didn't copy the entire name. So we have Samuel Kadima, containerization tut, and the version that we had there is version 1.0.0. So that is the one I'm going to run. So with this command, I should be able to run my image, a container from that image, and I should be able to access that container. I should be able to access the site on the browser when I visit port 8000. So let me do this. So yeah, so what it is doing right now, it's not printing the output on the terminal, and there is an issue with the data that is being presented. So I'm going to add some environment variables that are going to manage the file saving of the data and also the buffer, so that it can output the data instead of storing it in the buffer. So I'm going to add 2 environmental variables here. So one of them is, so in order to add an environmental variable, use env. So env is going to add an environment variable, not environmental, an environment variable. So this environment variable is going to tell Python this contains something. It's going to pass some information into Python, and Python is going to respond. So the environment variable, I'm going to write 2 of them. So the first one is Python, don't write bytecode. Python, don't write bytecode. So when I equate this to 1, it's not going to write bytecode. So, and then the other one that I'm going to add is Python unbuffered. So that everything, nothing is stored in the buffer. So I do Python unbuffered. And I also equate this to 1. So that way, we expect now to see our data. So we'll have to build this image again. So let's say now let me just do Control-C here so that we exit that. So I'm just going to do Docker build again. So I'll just do clear here, and I'll do sudo docker build. So I add the tag that I had. So I start with my name, and then the name of the image. So we said containerization tut. But now we've made some change, so we can change the version to 1.0.1. So that is our new version. So and I'm building this from this context. So I think that is okay. So it's doing it fast because this has been cached. All the layers have been cached. So I can go ahead and run this image, this one that we've created here. So let me just copy that name and run that container. So I can do docker run again and attach the port 8000 on my local machine to 8000 inside the container when it's running. So, and I'm running, which image am I running the container from? I have to put the name of the image there. So let us try this and see. So it's running. So once we do that, our container is running, and we can be able to access from this container. We can go to our browser and visit localhost 8000, and we should be able to access our browser, our website. So there it is. So we are now be able to see our application on the browser. So I think even if you change this to localhost so that it makes sense, you should still be able to see the website. Localhost 8000. Yeah, so you see, so we are accessing this from your localhost, but you are seeing what is inside the container. So up to that point, so the last thing that we are going to do is push this to Docker Hub. Now that you verified the image has been created correctly, and you can be able to create a container from it. So I can go ahead and push it to Docker Hub. So the first thing I do is Docker login. So I do sudo Docker login. So once I do that, it's authenticating, and once it authenticates on your, it has logged in automatically, but on your end, you'll put your username and password for your Docker Hub. So once it has done that, I can do use a Docker push command. So let me use sudo Docker push, and I refer to the image. So which is Samuel Kadima Containerization. That is the image I'm pushing to Docker Hub, Tut version 1.01. So once I do that, it's preparing and it's pushing to Docker Hub. So while it's finishing, let us look at our Docker Hub. So on our Docker Hub here, we do not have that application. So when we refresh, once it's done, we should be able to see it here. So let us go ahead and see. So I go to here, and we wait for it to finish pushing. So it's still pushing. So once the progress is 100%, we should go to our Docker Hub, and our image should exist on Docker Hub. So we wait a little bit. It's almost there. So almost done. Okay, thought it is. So it seems you're going to wait a little bit, but that is the last thing. So we are going now. The next thing is just questions that we can respond to. So it has pushed. So let us refresh our page. So you can see there it is. So you can see the version is not indicated here, but versions are indicated under tags. So if you go to the tags section, you can be able to see that we have some tags here, version 1.1. So you can be able to access this image using Docker pull. So if you want to pull it into your container, to your computer, you can do Docker pull. So I think that is okay. Let's see public view, what you are expected to see on your end. So it's Docker pull. So you can copy this and pull it into your computer. Okay, so that is it, guys. What we are covering today. So I can take any questions. Where is the browser now? Where is the meeting? So any questions? Yes, Victor, Max.
Okay, so like let's say you had a lot of maybe images to do the same with. So would you just do them one by one, or there's a way of just shortening everything and create all the images at once?
So
Yeah, like
you have yes,
like I saw you used like you're creating an image for Python, right? So
yeah.
let's say also you had other images that you wanted to create. So rather than just doing this step by step, maybe for each and every image, is there a way to do them all at once?
Yeah. So you can maybe in your CI/CD process you can automate that. So and ensure that you build. So with all automation tools, I think they can allow you to do that. You can use Ansible, you can achieve that. You can use CI/CD tools. You can still be able to to achieve that. It's possible to automate. So when or every time, because you do not want to be building manually, so you can just write scripts that can allow you to do that. You can even write scripts yourself. Yeah. Is there any other question?
We have a question on chat.
Okay.
What about containerizing the backend and front end separately? That's
Yes.
from Bradley, and then we have Cyrus who's saying, let's say you are dealing with API keys in your app. How do you handle that?
Okay. So when you are containerizing, you're actually advised to separate different applications according to what they are doing. So you are separating them into microservices. So if it's a front-end application, you want it to be separate from backend. So the best way is for you to create separate Docker files for backend and frontend, and build separate containers, have separate images for those applications. Are you answered? Do you feel answered? So we've just done a demo on how to deploy an image, David. I'm seeing David here saying we do a demo to deploy an image. That is what we've done, pushing to Docker Hub. So you can watch this video. We're going to post it to Docker Hub. So maybe if you didn't get that, you can just watch the video and you'll be able to see that. Dalton?
I'm wondering if someone does Docker pull on their end, like I do Docker pull on your repository that you have pushed. So will I get the same environment as you?
You will get that image, and when you containerize applications, they will run on all environments. So even if you are on a Windows machine, you are on a Mac, you can be able to pull that image and it will create a container on your computer without any issues, because everything is packaged within the container. So it's independent of your operating system and anything that is running on your computer. So it will work the same.
Okay, thank you.
You're welcome. So let me see. I think that is it. Yes, Bradley? Bradley, you have a question?
Yeah, can you hear me?
Yes.
Yeah, it's still about the containerization of the backend and the front end. Because I've been
Okay.
trying to do that and I'm not sure how I can do it in a Django application.
So we've just done a Django application here.
Mhm.
So what is your challenge?
Like the backend is in Python and the front end maybe could be in React or HTML. So how could you separate both of them?
So if it's in React, then React is a JavaScript framework. So you're going to
Yeah.
find a base image that is JavaScript based, like Node. And then when it's a Python application, you use a Python based image. But you go to Docker Hub and you explore the images that are there, and you find a small image that you can use as a base image or a suitable image
Yeah.
for you. So you just go to Docker Hub and look at which images can be used as base images there for your application, and you can even search online. So just feel free based on your application. So you create Docker files separately based on what you are. If it's a React one, ensure that it's a separate Docker file from the one that you are going to create for Python.
Oh, okay. Thanks.
Okay, you're welcome. So yes, Joseph.
Yeah, I think I want to add more context to Bradley so that he can get more insight on the same.
Okay.
Yeah, so when Dockerizing front-end and back-end, now this is where you have to go an extra mile and remember the existence of web servers. So we have Nginx and Apache. So I think that's where he has some problems. So put that into context, Bradley. That is adding Nginx, and you'll be sorted.
Okay. So I think is there any other question, Dalton?
Yeah, I'm sorry to disturb you with this question. I'm a beginner in this Docker stuff.
Okay.
Yeah, I was wondering because I'm an Android dev. So when I push like an image to the Docker hub, then let's say the other guy pulls the image to their machine. Since you have said it is independent of any operating system, what will they need to run the image considering like all the files, the Gradle dependencies, the front end, back end?
Okay, that is a good question. So we've said in the container you're going to package the application with all its dependencies. So Gradle is one of the dependencies, isn't it, for that application?
Yeah.
So Gradle is going to be part of that container. So you are going to use a Java-based base image on that application, and it's going to provide then everything that you would have installed on any computer before you run an Android application will already exist in that container because that container has the application plus all dependencies. So even if that person is on a Windows machine, so long as they have the container run engine, the container engine like Docker in their computer, and it's a Docker image, once they just run Docker commands, they will function the same on every computer, and the commands are the same. So whether we've installed Docker on Mac or Linux or Windows, Docker run is Docker run on all of them. Docker pull is Docker pull on all of them. And once you run the container is not depending on any dependencies that are on your host computer. All the dependencies that are already provided in the container when it runs. So if it has everything it requires within the container, it should be able to run on any computer, and everyone should be able to run it.
Okay, that's clearly tough. Yeah.
Okay. Good. So I think is there any other question, Ivy, that I've left?
Not really. You've covered everything.
Okay.
So maybe what you can do, I can share the screen for people to scan the QR codes for joining the community.
Okay. That is okay. Yeah. So that is it, guys, from my end. Thank you for listening. So back to you, Ivy.
Thank you so much, everyone, for joining the session today. I really hope that you have gained something from the presentation today. If you have any follow-up questions, we can continue the same discussion on the community channel. Be sure to engage, and I hope you can learn more. So here are the QR codes for joining the community. Our LinkedIn, our WhatsApp, our Twitter, and our Discord channel. You can just scan it and then you'll be able to join the community. Otherwise, see you in our next session. Yeah, thank you so much for joining. So I'll leave this for a while so that you can scan. Thank you so much. See you next time. Have a good night.